Hello dear students, welcome to Royal Palace PU College online classes. Dear students, today in this session we shall start with the topic that is probability. In the previous session we have discussed about the topic called as conditional probability. Okay, conditional probability. What do you mean by that conditional here? That is conditional probability. Okay. Now, what do you mean by that probability? That is very simple. That is a probability of A already B has occurred. Okay. Already B has occurred. That is nothing but here P of A bar B here. P of A bar B. That means here according to definition of the conditional probability, that is P of A already B has occurred, or probability of A given B, it is denoted and defined by P of A intersection B divided by P of B. That is nothing but the definition of our conditional probability. Now, depending on this conditional probability, already we had looked onto the exercise number 13.1. Now, today in this class, let us start the next exercise, that is 13.2, that is related to both multiplication theorem as well as independent events. Now, let us discuss one by one what do you mean by these two. That is, one is a mathematical theorem here. Now, let us discuss about it. Let E and F, okay, be two events, okay. That means here let E and F be two events. Then by conditional probability, okay, that is nothing but by conditional probability. So we know that what we are knowing by conditional probability, that is P of E bar F is equal to P of E intersection F divided by, dear students, P of F here. That means here the same theorem I can write as P of E intersection F, okay. P of E intersection F equal to this denominator I will multiply here. Andre ಏನು ಬರ್ತದೆ ನೋಡ್ರಿ, P of F into P of E bar F here. So this itself we know to be as multiplication rule here. This rule is known to be as multiplication rule of probability, called as multiplication theorem or rule. Now here, dear students, some of the times what we have are P of E bar F you are having, sometimes we have F bar E, that is nothing but P of E intersection F divided by P of E here, divided by P of E. Now I will multiply here P of E. Okay, dear students. So what we get here, that we shall look on to. Now here what we get is, that is a P of E intersection F. Okay, the value will be P of E into the whole thing, that is a P of E, okay, dear students, into P of F bar E according to the definition. This is also known to be as, that is multiplication rule here. Okay, that is nothing but called as known as multiplication rule. Now here, dear students, one thing we have to observe that is here P of E intersection F is also known as, also written as, that is a P of EF, is also written as P of EF. EF means E intersection F, and here the thing is, here E and F, okay, that is a P of E bar F should be here, both are dependent on each other. That is one thing. This is one particular idea here. This is all about the multiplication rule here. Now, dear students, let us observe what do you mean by here independent events. Now, independent events that we shall observe. Independent event. So, according to definition of the independent event, okay, what do we have according to definition of independent? That is, if we are having two events E and F, okay, E and F are said to be independent, okay, are said to be independent. Suppose, let us take an example here, let us take 2 coins. If you are throwing both the coins at once, what happens here? Here in this coin I may get tail or head, here I may get head or tail. That means the happening and non-happening of this event is not at all related to happening and non-happening of this particular event. That means here, let us take it as E and F. E intersection F will be 0, or it is nothing but null side. Very simple thing. That means according to the independent event, so here P of E intersection F, that is nothing but here null set, or N of E intersection F will be 0 here. Now let us look onto the theorem here. What is that? P of A union B, that is nothing but here P of A plus P of B. Okay, dear students. Okay, next what we have? One more. Just now we had looked onto the, here we have taken E and F as the events. Now here what we have here, we had looked onto the definition, that is a P of independent events. Okay, dear students, this is one particular, that is definition of independent events. Now let us look onto the independent definition related to this particular, that is conditional probability. That is what we require here. This is all about the definition of independent events. Now we shall look onto this independent event related to our conditional probability. What we have now here, P of E bar F. Dear students, what do you mean by this P of E bar F? That is nothing but here probability of E given F, or else probability of E already F has occurred. What do you mean by that? Already F has occurred. But what happens in this independent event is, since E and F are independent event, so probability of E is not at all related to probability of F. Therefore, probability of E bar F, the value will be probability of E itself. What it is? The probability of E itself. Okay, that is in this independent event. Therefore, what we can take is, therefore, now here according to this particular equation you can take it as 1. Therefore, from equation 1, P of E intersection F, that is nothing but here P of F, okay, into what can write is P of E here, because above, that is nothing but P of E bar F is equal to P of E. That is by making use of the simple definition, that is probability of E already F has occurred. Whether F may be there or whether F may not be there, that is nothing but immaterial. So what it is? It is nothing but our probability of E here. So therefore, according to definition of independent event, it is an definition, that is for independent events. That is here E and F are said to be independent. What is the condition here? That is P of E intersection F is equal to P of E into P of F. That is nothing but the result required to independent events. And the result required for the multiplication rule, that is P of E intersection F equal to P of E into P of F bar E. F bar E means probability of F already E has occurred. Okay, dear students, this is nothing but our simple example related to, or the simple basics that is required for the multiplication rule and as well as the independent theorem, independent events. Okay, dear students, now let us look onto the exercise number 13.2 related to this particular probability. Till that, please pause the video to note it down. Okay, dear students, now let us move on with the exercise number 13.2. Let us move on with the first question. If P of A is equal to 3 by 5, P of A means probability of A is equal to 3 by 5, probability of B is equal to 1 by 5, find A intersection B, that is probability of A intersection B, if A and B are independent events. Now here what he has given is, since A and B are independent events, that is P of A intersection B is equal to P of A into P of B according to definition. Just now we had seen. That means here P of A intersection B are required to find here. Now P of A means what is the value? That is 3 by 5 into P of B value. What is the P of B value? That is 1 by 5. That means what we get? 3 divided by 25, and that is nothing but our required result for P of A intersection B. Very simple example. Okay, dear students, now let us move on to the second example. The second example is on the board, that is 2 cards are drawn at random and without replacement from a pack of how many cards? From a pack of 52 playing cards. So there in the playing cards, how many cards are there? That is nothing but 52 playing cards are there. Then that is n of s. That means n of sample space is equal to what it is, 52. Okay, that is 52 playing cards are there. First thing, find the probability that both the cards are black. Okay, we are having a set of 52 cards. In the first draw, that means here there are 2 draws. In the first draw, I will choose one card. Okay, I will choose one card that the probability are is a black card. That means if I am taking the first card, what is the probability that it is a black? Dear students, in this set of 52 playing cards, okay, dear students, there are 26 black cards, and here again 26 red cards. Okay, this is first thing. 2 colors, black and red, one thing. Then there are 4 types. Okay, what are those 4 types? Let us observe here 4 types. Okay, the 4 types are as follows. The first one is heart. Okay, that is a heart and a diamond. These 2 are always red. That means it is of this particular format. It is heart, and it is diamond. Then spade and club. Spade and club, these are always black here. That is nothing but spade will be of the type this particular, like a leaf here. Okay, and the club, okay, it will be of this particular type here. Okay, so all these are different, are nothing but a 13 types. These are 13, 13, 13 and 13. This is all about the playing cards, dear students. And in this playing cards, the number ranging from, okay, and the numbers from numbers, that is 2 to, that is 10, 2 to 10, and we are having that is J, Q, K, A. That means all these from 2 to 10, there are nearly up to, so here that is 9, 9 plus 4, that is 13. That's why there are 13 types. And all these 13 numbers, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K, A, that is Jack, Queen, King and Ace. So these are nothing but 4 different faces. 2, there are 4 different types. That is one is spade, one is club, one is heart, one is diamond. Similarly, the number 3, all one of different kind. Similarly, J, all one of different kind. And for Ace, all one thing. That is 2 are black, 2 are red. 2 are black means what? One is spade and one is club, heart and diamond. That is nothing but the explanation about our, that is playing cards, dear students. So here this is nothing but our club and spade. These 2 are always black color. And here heart and diamond, these are always red in color here. These are always black in color. Okay, dear students, now let us come back to our actual problem. What it is, find the probability that the card is black. The cards are black. So now let us let A be the 2 events are there. That means, of course, the set of 52 playing cards are there. 2 events means A be the event of choosing a black card, B be the event of choosing a black card. And one more thing you have to remember, that if you are choosing a card without replacement means what? And if we choose a card, we are keeping it aside. Again, we don't keep in that particular value here. So therefore, A be a event of choosing, that is nothing but here choosing a card. Let A be the event of choosing, that is black card. So now how many black cards are there? That is very important. So here there are 26 black cards. Okay, there are 26 black cards. So therefore, probability of A, dear student, that is nothing but here n of A divided by n of S. So n of A means what it is? How many black cards are there? That is nothing but 26 divided by 52. The value will be 1/2. Very simple thing. This is one thing. Now let us move on with the second thing. Let B be the event choosing a black card in first draw. It is first draw. Dear students, it is in first draw. Let B be the event of choosing black in second draw. That means here, now in this 52, already one has gone here. And in this 26 black, already one has gone. That means we have to choose. So now from remaining, That is, now if we require to find probability of B, that is a probability of that implies probability of choosing a black card already A has occurred. That means we require to find the probability, okay, probability of A already, that is probability of B already A has occurred. That means what we have, that is probability of B bar A. Now what is this probability of B bar A? That is how many cards are remaining. That is very important. That is 26, 1 has gone, the remaining part is 25. Out of this 52, 1 has also gone, that means it is 51 here. That is the value for P of B bar A. Now what we require is, we require both. That is, we require both. Find the probability that both the cards are black. That means probability of both cards are black is given by P of A into P of B here. What we can write here, that is P of A into P of B. That is nothing but P of A intersection B. According to the definition we have, that is P of A, okay, P of A into P of B bar A. That means P of A value is 1 divided by 2, and dear students, P of B bar A value is 25 divided by 51, and hence the value will be 25 divided by 2, 102 here. That is nothing but here probability of A intersection B here. Dear students, the problem is very simple. Some of the textbook what will give, P is the probability event of choosing black in the second row. Directly he will write P of B is equal to 25 by 51. That is also right. Why? Because B itself he has chosen is at that is probability of B already A has occurred. That it is quite optional, you may write or you may not write. Okay dear students, so these are the two problems related to our exercise number 13.2. Now let us continue with the problems related to the exercise. So before going to that, please pause the video to note it down. Okay dear students, now let us move on with the next problem here. What we have, it is very simple, that is a fair coin and a die is thrown. Okay, a coin is having how many faces? 2 faces, that is head and tail. Whereas the die is thrown, similarly die is thrown. Die is having numbering from 1, 2, 3, 4, 5, 6. 6 faces are there, 6 numbers. Both are thrown at once. Let A be the event, head appears on the coin. Okay. So first of all, starting with the problem, let us write the sample space. Now what is the sample space here? That is a fair coin and the die is thrown. Both are thrown at once. Okay. That means I may get it as head 1, okay, and then tail 1 I may get. Okay. Similarly, I may get it as head 2 and tail 2. Then I may get it as head 3, tail 3. Similarly, head 4, tail 4. Similarly, head 5, tail 5. Then head 6 and then tail 6. These are the 6 possibilities. That means both one die is thrown and the coin is tossed. These are the total possibilities that may occur here. That means n of s is equal to we are having, that is 12 dear students. Very, very simple. Now the next thing is thrown. A be the event of head appears on the coin. That is nothing but here A. A means what we have? Head appears on the coin. Head appears on the coin means only head we have to choose. That is head 1, then head 2, then head 3, head 4, head 5, and then head 6. Head appears on the coin, that's all. That means n of A is equal to how many? 6 here. Then similarly P of B. Now here similarly I will find P of A here. P of A is equal to n of A divided by n of S. That is nothing but 6 by 12, the value will be 1 by 2 here. Simple. Then given that B, what is the event B here dear students? B be the event of 3 on the die. Only 3, that is only related. Whether it may be head or whether it may be tail, that is not at all matter. 3 means what we have? H3 and T3. Okay dear students, H3 and 3. That means here probability of B, that is nothing but how many it is? N of B is 2 divided by n of S, that is 12. The value will be 1 by 6 here. One thing. Now we have to check whether A and B are independent or not. Independent means what here? P of A intersection B is equal to P of A into P of what we have, dear students, that is P of B here. That means here that also A intersection B is equal to, what is A intersection B? A and B. What is the B? H3. H3 is the only common thing, that is H3. That is nothing but here N of A intersection B is equal to 1 here. Okay. Now let us look onto the probability of it. Probability of A intersection B is equal to N of A intersection B divided by N of S. The value is 1 divided by 12 here. That implies here by independent event we have that is P of A intersection B is equal to P of A into P of B. That is 1 by 12 is equal to P of A means what we have, dear students, that is nothing but here 1 by 2 into P of B means what we get here, that is 1 by 6. That implies 1 by 12 is equal to 1 by 12. Therefore A and B are independent events. So what we can tell, therefore A and B are independent. Therefore A and B are independent events. One thing. This is the first part. Then let us move on to the second thing, that is a die marked 1 2 3, okay, die marked 1 2 3 in red, okay, and 4 5 6 and 4 5 6 in green is tossed. Okay, what it is, a die marked 1 2 3 is red, 4 5 6 is green, is tossed. Let A be the event. Okay, now what is the sample space here? The sample space will be, of course a die is thrown. In this die what happens, number 1 2 3 is red in color and 4 5 6 is green. Whenever we toss a die, what happens here, we'll get it as 1 red, 2 red, okay, or else we get 3 red, or else we get 4 green, okay, 5 green and then 6 green. These are the possible cases. That means N of S here, N of sample space, the value will be 6 here. That's all. Now let us take here event is tossed. Let A be the event. The number is even. Okay, what is given? A is equal to number is even. That's all. Even means what it is? 2, 4, 6. Now here 2. What is the color of 2? It is the red here. It is green and it is green. One thing. That means probability of A, that is nothing but how many values are there? 3 divided by N of S, that is nothing but 6. The value will be 1 by 2 here. Simple thing. Similarly, the event B. Event B means what we have, and B be the event. The number is red. Only red number is there. That means here 3, 1 red, 2 red, 3 red. That's all. Only 3 are there. That means probability of B is equal to 3 divided by 6, that is also 1 by 2. How many red are there? 3 reds divided by N of S, that is nothing but 6 here. Finished. Now for independent events, we have to show that are A and B and independent. Independent means we require to find P of A intersection B equal to P of A into P of B. P of A intersection B now. Now A intersection B, dear students. A intersection B means what we have? 1, 2, 3, here 2, 4, 6. Only the 2 is common. That means here probability of A intersection B is equal to 1 divided by how many? That is 6 here, 1 by 6. Therefore, by independent events for A and B to be independent, we have that is a P of A intersection B is equal to P of A into P of B here. P of A into P of B irbekangarele. That means what we have, P of A intersection B. What is the value for A intersection B? That is 1 by 6, which is equal to P of A. P of A under 1 by 2 into 1 by 2. So ultimately what we get is 1 by 6 equal to 1 by 4, and it is not equal. Therefore, what do you mean? You mean that implies here A and B are not independent, That is your simple logic behind this problem. Independent means it should be P of A into P of B, P of A intersection B equal to P of A into P of B we should have. LHS equal to RHS we should have. But that doesn't happen in this case. therefore it is not independent, and the first problem it is independent. Okay, dear students, in the next class we shall continue with the problems related to this particular exercise, that is 13.2. Till that, thank you.